Imagine Earth before the first animals appeared, a world shrouded in silence, where the only inhabitants were invisible to the naked eye. The landscape was stark and alien, shaped by relentless geological forces and the slow passage of time. There were no forests, no bird song, no footprints in the mud, just a quiet planet, ruled by the smallest forms of life. For billions of years the oceans were home to single-celled organisms and soft-bodied creatures, their existence barely leaving a mark in the fossil record. These early life forms thrived in the darkness, forming vast microbial mats that blanketed the seafloor, quietly shaping the chemistry of the planet. This was the Ediacaran period, a time of slow, almost imperceptible change, where life remained simple and unhurried. The oceans teemed with strange, soft-bodied organisms, unlike anything alive today, drifting gently in the currents. Life was passive and peaceful. There were no predators or prey, no chase or escape, just mats of bacteria and jelly-like beings floating in the deep, undisturbed by the drama that would one day unfold. The continents themselves were unrecognizable, clustered together in a supercontinent called Pannotia. The land was barren and harsh, shaped by volcanic activity and battered by ancient storms. The air was thin and low in oxygen, with a hazy atmosphere still finding its balance. Volcanic eruptions and chemical reactions in the ocean slowly transformed the planet's surface and sky. There were no eyes to see, no brains to think, and no movement beyond the gentle sway of the water. It was a world in waiting, suspended in a long, silent pause before the next great act. Yet, beneath the surface, the chemistry of life was being perfected. Hydrothermal vents and tidal pools became laboratories for new molecules, setting the stage for future innovation. For over 3 billion years, this was the norm. The planet's history was written in slow, patient strokes, with life evolving at a glacial pace, but even in this apparent stillness, potential was building. Deep within the oceans and mud, new possibilities were quietly gathering, waiting for the right moment to ignite. The transition from this simple, tranquil world to one bursting with complex animals would become one of Earth's most dramatic and awe-inspiring transformations, a true revolution in the history of life. The planet was on the verge of an evolutionary leap, as if the world itself was holding its breath, waiting for the dawn of something extraordinary. The curtain was about to rise on life's greatest act, a burst of creativity and complexity that would forever change the face of Earth. Then, everything changed. About 541 million years ago, life exploded in diversity, the Cambrian explosion. In just 20 million years, simple life gave way to a riot of complex animals. Suddenly, fossils of creatures with shells and exoskeletons filled the rocks. This wasn't a literal explosion, but a burst of evolutionary innovation. Nearly every major animal group appeared: arthropods, mollusks, chordates, our own distant ancestors. The Cambrian marks when life began leaving its story in stone. It's the dawn of the animal kingdom as we know it, the basic blueprints for animal life. Heads, tails, legs, eyes were set. Every animal alive today traces its roots to this extraordinary event. Let's dive into the Cambrian seas and meet its stars. Trilobites, the most iconic, were armored arthropods with complex eyes scurrying across the seafloor. They came in thousands of species, from tiny to over 2 feet long, adapting to every niche. Some burrowed, others hunted, and their hard shells made them fossil legends. But trilobites weren't alone. Hallucigenia walked on spines, Wiwaxia bristled with scales, and early mollusks built the first shells. Brachiopods anchored to the seafloor, filtering food. Most crucially, the first chordates, tiny fish-like pacaya, appeared, ancestors to all vertebrates. The Cambrian was a bustling metropolis of evolutionary experiments. Our own family tree began as a humble branch here. In these ancient seas, life's diversity truly took off. Every ecosystem needs a top predator, and in the Cambrian period, that role was filled by the remarkable Anomalocaris. This was a time when life was just beginning to diversify in the oceans, and the arrival of such a formidable hunter would change the course of evolution forever. For years, Anomalocaris puzzled scientists. Its fossils were so strange that early paleontologists thought they belonged to several different animals. Only after careful study did they realize these pieces formed a single 3-foot-long super predator, one of the largest and most fearsome creatures of its time, with its enormous compound eyes, spiny grasping arms, and a circular, tooth-lined mouth. Anomalocaris was perfectly adapted to hunt. It preyed on trilobites and other soft-bodied animals, using speed and agility to ambush its victims and dominate the Cambrian seas. The rise of predators like Anomalocaris marked a turning point in Earth's history. For the first time, animals had to contend with being hunted, and this new pressure would spark a wave of evolutionary change. Suddenly, survival meant more than just finding food. Prey species had to evolve new defenses: thicker shells, sharp spines, and the ability to burrow quickly into the seafloor to escape danger. This predator-prey arms race drove rapid innovation, pushing both hunters and hunted to develop new strategies and adaptations at an unprecedented pace. Speed, armor, and camouflage became essential tools for survival. Some animals grew tougher exoskeletons, while others learned to blend in with their surroundings or move with lightning speed. This feedback loop between predator and prey accelerated evolution, weaving a complex and interconnected food web that supported a dazzling array of new life forms. Anomalocaris wasn't the only predator in these ancient seas, but it was certainly the apex. Its reign at the top of the food chain set the stage for future marine ecosystems. The mere presence of such a powerful hunter forced prey to adapt or face extinction. Fossil evidence of bite marks and damaged shells tells the story of this relentless struggle. The Cambrian seas became a dynamic, competitive world, teeming with life forms locked in a constant battle for survival and supremacy. Predation added drama and urgency to life's story, turning the ancient oceans into a stage for innovation, adaptation, and the relentless pursuit of survival. Evolution had found a new engine: fear. The legacy of Anomalocaris and its fellow apex predators still echoes in the diversity and complexity of life we see in our oceans today. What fueled this explosion of life? Oxygen. For eons, Earth's atmosphere and oceans had little oxygen. Cyanobacteria slowly changed that, pumping out oxygen and transforming the planet. By the Cambrian, oxygen levels finally reached a critical threshold. Oxygen is high-energy fuel, enabling bigger bodies, faster movement, and complex tissues. Without it, animals like Anomalocaris couldn't exist. The oxygen surge didn't cause the explosion, but it made it possible. Like electricity powering a city, oxygen powered complex life. Ancient rocks show a spike in oxygen just before the Cambrian burst. While not the whole story, oxygen was a vital trigger. The world was finally ready for animals to thrive. Opportunity alone wasn't enough. Life needed new tools. Enter Hox genes, the master architects of animal bodies. These genes control where heads, tails, and limbs grow, shared by nearly all animals. Before the Cambrian, the genetic toolkit was basic. The evolution and duplication of Hox genes allowed rapid experimentation with body plans. Small genetic tweaks led to big changes: extra limbs, new shapes. This flexibility unleashed a wave of diversity. The Cambrian explosion was powered by both environmental change and genetic innovation. Once complex animals appeared, they didn't just inhabit their world, they began to transform it, and in doing so, they transformed each other. The arrival of these new life forms set off a chain reaction that would ripple through the oceans for millions of years. Predators forced prey to adapt, driving the evolution of hard shells, sharp spines, and clever burrowing habits. Each new defense sparked a new offense, as predators evolved sharper teeth, stronger claws, and faster bodies. This evolutionary arms race fueled rapid specialization, with animals branching into new forms and filling every available niche. The diversity of life exploded as new species emerged, each uniquely suited to survive in a changing world. Burrowers, in particular, transformed the seafloor. By digging and churning the sediment, they released nutrients and oxygen, creating entirely new habitats for other organisms to exploit. These ecosystem engineers didn't just adapt to their environment, they actively shaped it, altering the ocean's landscape forever and paving the way for even more complex communities. The Cambrian substrate revolution opened up life beneath the sediment, allowing animals to colonize new spaces and interact in ways never before possible. Each evolutionary innovation created new opportunities, sparking further bursts of adaptation and competition. The ocean became a living laboratory, where every change set off a cascade of new possibilities. As oxygen levels rose, animals became more active, which led to more predation, which in turn led to new defenses and strategies for survival. The pace of change accelerated and life became more dynamic than ever before. The result was a positive feedback loop, a self-reinforcing cycle where diversity bred more diversity, and every adaptation opened the door to even more evolutionary experiments. The Cambrian explosion wasn't a single event, but a biological wildfire, spreading innovation and complexity through every corner of the ancient seas. Life's creativity fed on itself, multiplying and spreading rapidly through the oceans, filling every available space with new forms and behaviors. Evolution became a cascade of cause and effect, a never-ending interplay of adaptation and opportunity that continues to shape life today. The world was never the same. The legacy of this ancient feedback loop is still visible in every thriving ecosystem on Earth. Despite our theories, the Cambrian explosion remains a scientific enigma. Why did it happen so quickly, and why then? The fossil record before the Cambrian is sparse, making the transition seem abrupt. Was it a missing chapter, or did life really change overnight? Oxygen, genes, and ecology all played roles. But how did they combine? Untangling this ancient web is a challenge for geology, genetics, and paleontology. Each new discovery brings us closer, but the full answer may always elude us. The Cambrian explosion reminds us how much we still have to learn. Why does this ancient event matter to us? The Cambrian explosion is our origin story, the moment animal body plans, including ours, were forged. Our earliest ancestor with a backbone swam in those seas. Studying this event reveals how life can change rapidly, with something for today's world. It shows how environmental shifts can reshape life on a planetary scale. The Cambrian is a story of chance and contingency. If things had gone differently, so would we. We are the descendants of those first pioneers, connected to their improbable journey. Their story is our story, written in our DNA. By unraveling their mystery, we understand our own. The Cambrian explosion is a testament to life's creativity, and our place in its grand adventure.